Today I'd like to present to you some aspects of the work we've been undertaking over the last few years on bioregional assessments in the Galilee Basin. Before all that, the bioregional assessment acknowledgement. And aside from what's in the acknowledgement, I'd like to personally acknowledge the considerable efforts the Galilee Bioregional Assessment team have undertaken to bring the BAs to its fruition. And so what am I going to present to you today? I'm going to outline what is a bioregional assessment. Some of you will already know, some it may be new concepts. I'm going to introduce you to what is the Galilee Bioregional Assessment area, how is it defined, outline some of the key geoscience questions that we thought were pertinent to the Galilee Bioregional Assessment, outline some of our new findings around geology and hydrogeology for the area, try and show why the new conceptualisations that we came up with as part of the work is important, and then conclusions and knowledge gaps, because there's always often further work required. So what is a bioregional assessment? Well, officially it's assessment of the potential direct, indirect and cumulative impacts from coal and coal seam gas mining developments on water resources and water dependent assets. And some of the aims of the Bioregional Assessment Programme include assessment of cumulative risks and cumulative impacts and risk to water dependent assets at a regional to semi-regional scale. We're required to use a methodical approach that can be adapted across different bioregions, and as you'll see there was more than one. Our work is to inform management and decision making around coal and coal seam gas developments. And who is it to inform? The IESC, which is the Independent Expert Scientific Committee, which provides advice to regulators around coal and coal seam gas, informs state and federal agencies and also to the community. The science that we do has to be transparent and repeatable, and has to be available to all, and I'll show you where you'll be able to get the data and the reports at the end of this presentation. Another aim is to identify knowledge gaps and provide some direction for future research. So what is a water dependent asset? What do I mean by that? So essentially, because the water dependent assets, they are the thing in which the bioregional assessment methodologies are assessing impact against. So what is a water dependent asset? There's a lot of discussion in BAs over this in the early days, I can assure you. But essentially it's something which the community values that is reliant in some way on surface water and groundwater. So that can be a groundwater dependent ecosystem, it could be river red gums, it could be a surface water or groundwater resource, it could be springs, town water supply, bores, and who decided if these assets were important or not? Well, there are a variety of people. Firstly, it was communities through, communities provided us with what they thought was important, then state and federal agencies, and overall there's a comprehensive list of water dependent assets compiled into one large database, and it came from 24 data sources, state, federal, local. So who was involved in the bioregional assessment? Well, as mentioned in the acknowledgements, it was a partnership between the Office of Water Science, CSIRO, BOM and the Bureau of Meteorology and GA. Directly, there was more than 120 people involved in the bioregional assessment program over, it's actually more than 5 years, it's 4 years, it's closer to 5. In the Galilee Bioregional Assessment team, at times there are up to about 25 people working on the project. Now, aside from the Commonwealth involvement, there was a lot of, the projects had a lot of collaboration and input from the state agencies, as well as academia, and including consultation with relevant industry proponents. As Stuart mentioned previously, the project teams are actually multi-disciplinary, and my team had team members from both GA and CSIRO. GA provided the earth science side of things, the geologists and hydrogeologists for Galilee. whereas CSIRO provided discipline expertise around ecology, hydrology and risk analysis. And the Bioregional Assessment Programme, actually there's quite a number of these projects, 13 in all, and where were they? Well, I'll show you. So essentially they were in eastern and central Australia. Essentially these projects were defined by the occurrence of coal-bearing sedimentary basins, and GA had carried project lead for these four: Pedirka, Arckaringa, Cooper and Galilee, and also Gippsland as well, whereas CSIRO were the project leads for a group known as the Northern Inland Catchments, which basically was looking at coal developments in the Gunnedah and Surat basins, Clarence Morton Basin, the Sydney Basin, and then there's a little one out here called Gloucester, which is basically like an extension of the Sydney Basin in a way. But our main four were these ones up here. Arckaringa and Pedirka were undertaken jointly with extensive input by the South Australian agencies, whereas Galilee and Cooper were more done in-house within GA and CSIRO, within the Bioregional Assessment Programme. So now that's a bit of background for the Bioregional Assessment. I'd like to introduce you to the Galilee sub-region. So the Galilee sub-region, which is basically this black line, there's the boundary. The Galilee sub-region is defined by the Galilee Basin, and it's a coal-bearing basin, but Galilee Basin margin. And the Galilee Sedimentary Basin has significant coal resources and encompasses an area of some 248,000 square k's, which is actually a bit bigger than my home state of Victoria. So large area. Essentially there's a number of features, and it's located in central to Western Queensland. Number of interesting features. The Great Dividing Range occurs along the eastern margin, and so you end up with westward and eastward flowing river systems, which can be assets. There are a number of national parks which were included in the assets list for consideration. Some major lakes in the highlands, Lake Galilee, Buchanan among others. A number of spring systems including Doongabulla and Edgbaston Springs, and a host of other things, town water supplies, great artesian basin aquifers to the west of this range here, out here, and essentially, but the interesting thing with the Galilee sub-region compared with a lot of the other regions was compared to the Sydney Basin, Surat, Gunnedah, this is a greenfields area. Currently there's no coal or coal seam gas developments in production. There's some projects that are at a very advanced stage. The only project that was in production at the time when the Galilee BA commenced was the Gilmore gas field, which is a conventional petroleum gas field, and as it's not related to coal and coal seam gas, was out of scope for Galilee BA. We just note it's there, and that gas field occurs in the Adavale Basin, which underlies the Galilee. So as our focus is coal and coal seam gas, where are they in the Galilee Basin? Are they everywhere? Well, no. They occur. So we are, as part of the Galilee Bioregional Assessment, we identified 14 coal projects and 3 coal seam gas projects. The resources for the majority of the coal projects were the upper Permian coals in the Galilee Basin, and that's this cluster of projects along the margin here. The only project that wasn't tapping into was the Blackall project, which was assessing brown coal in the Winton Formation, which is part of the Eromanga Basin. The coals in the Galilee Basin are thermal coals, so they'll be used for energy production or production of gas, where you've got the coal seam gas projects. Not all of the projects at the same stage of development, which has a significant bearing for how which has a significant bearing on how the projects are incorporated into the bioregional the impact analysis which is done as part of the bioregional assessment. So for instance, the ones that are in blue, South Galilee, Kevin's Corner, Alpha, Carmichael, Chinastone and Hyde Park, these projects were at a fairly advanced stage. For instance, they may have been at most of them were at an environmental impact statement stage of their permitting. Some of them have had their permits granted. So there's quite a bit of information available for these 7 projects that are in blue. And so these projects were included. These are the projects that our groundwater modelling and surface water modelling determined impacts on. So our modelling was based on what was the potential impact from these projects. Now other projects were more at an exploration phase, such as this cluster up here and Blackall. So they've defined a resource, but there's no real timeline about when they may develop. In fact, with some of them we didn't even know whether they'd be open cut or underground. So these ones weren't included in the quantitative modelling phase of the bioregional assessment. However, they become part of the commentary in the impact and risk analysis report. So they weren't forgotten completely. It's just a different style of reporting for those. Coal seam gas projects are these 3. Glenarris is the most advanced, again these ones the timing of development was a bit uncertain, so they became part of the commentary. However, they were still, as you'll see. So I forgot to mention the deepest proposed mines around about 450 metres, and these most advanced mines are a mixture of open cut and underground. Here's an example. At the Alpha coal mine they dug a test pit down to about 66 metres, and I think they extracted about 100,000 tonnes of coal just to test how they would process it. The Glenarris pilot CSG gas field over here, they've been doing long-term pumping tests to determine the viability of gas production, how much water they may produce, how they'll handle it. So that's the projects. Now Galilee, as I said, straddles the Great Dividing Range, and it actually encompasses 6 major water catchments, and as well as those lakes. And the 2 catchments, which was a bit of a headache for the surface water modellers, because that potentially meant 6 surface water models. But thankfully we managed to settle on one, which was to build. But thankfully we managed to settle on one area, and so the surface water modelling focused on the Pedirka River catchment, in particular the Baliando River, which runs along the margin of the Galilee. And the reason surface water modelling was only done here was because all those, the most advanced mines all occurred in the headwaters of the Baliando, so they're just along here. The CSG occurred over the divide in the Cooper Creek catchment, but that was more qualitative. Oh, technology failure, okay, or user failure really. Okay, so now a bit about the surface geology. So the Galilee. So why are the coal mines over here? Well, that's where the coals come to near surface. So essentially, as I'll show you in some cross sections that are to come, the coal measures they outcrop along the east of the Great Dividing Range, along a belt along here, and that's where most of the coal mines are. As you head progressively west, in particular once you get to the west of this line, the coal measures and the Galilee Basin is buried by another overlying basin called the Arckaringa Basin, and as I mentioned, the coals are Permian in age, and these coals are actually an equivalent to coals found in the Cooper Basin, which is down in this area, not shown, and the Surat, which is off to the east here. Another feature is there's quite extensive Cenozoic cover overlying both the Arckaringa and the Galilee, and but it's relatively thin, but it does have a significant bearing on some features of the groundwater systems. In fact, it affects recharge quite considerably. As a geologist, I can't go past a stratigraphic column. And so over here is the Arckaringa Bay. This column over here represents the stratigraphic units that occur within the Galilee subregion that comprise part of the Arckaringa Basin. So you got the, and so if it's yellow, its units are predominantly sandstone. The oranges are more a mixture of interbedded sandstone and siltstone. The rolling downs group up here, there's predominantly shale, siltstone, bit of sandstone, and then back into a sandy sequence into Winton. Again, for the over here is the Galilee stratigraphy. You've got these sediments down here. The JoJo group were deposited in a where there's glacial influence that affected these. These were deposited a glaciogenic sediment, so there's some glacial influence in the way they were deposited. There's some also some fluvial sandstones, a lot of volcanics. There's these aromatic coal measures in the early Permian. They don't outcrop, they're only found along the western margin of the basin and were an exploration target for CSG. But the main target in the whole of the Galilee subregion was the upper Permian coals, which consists of a number of stratigraphic units, the Colin sandstone, the Bandana Formation. There is a marginal marine sequence, which is the Black Alley Shale and Bandana Formation. That was mainly found in the southern parts of the Galilee. And then this is overlain by a fluvial sequence, the Clematis group, Mulliamba and the Rewan. Yes. And again, so there's the upper Permian coal measures. It's a mixture of, coal. There's quite a bit of sandstone in the Colin Lee, some shales and mudstones. The Bandana is a lot more siltstone, mudstone dominated. And the complex lithology that occurs in the upper Permian has a bearing on the groundwater systems in there. They're quite complex. So some of the questions that we thought were key to answering, fulfilling the aims of the Galilee Bioregional Assessment were, right, in actual fact, when we started regionally, there wasn't much information on how the Galilee Basin groundwater systems work. They'd never actually been mapped regionally before, so that became one of the aims. Does the subsurface geology influence groundwater flow? What's the potential for connectivity between the coal measures, major aquifers such as the Great Artesian Basin and other aquifers in the Galilee? Are there data and knowledge gaps? Yes. And which I'll show. And will water-dependent assets such as your creeks and your water resources be impacted by coal and coal seam gas? Now I've put this question in here, but it's not one I'm going to necessarily answer today. That'll be subject to, it's not necessarily one I'll be answering today. We're still finalising the reports on that one. Okay, so we also noted at the time there were a number of data gaps. We needed some new information and interpretations to answer some of those questions. So some of the work we did as part of the Galilee Bioregional Assessment was we updated the mapping of the Galilee Basin subsurface geology. We're able to, prior to the Galilee Bioregional Assessment, last time it was done was about the late 1980s, and since that time there'd been about 100 coal seam gas wells drilled, so there was new information in deeper parts of the basin. You had the coal mines do a lot of drilling, so there's new information from there as well. We developed a regional Galilee geological model and hydrogeological models, and I'm going to present some of the Galilee geological model today. The geological model was a combination of the new mapping that we did in the Galilee Basin, and that was accompanied by some of the previous work that had been done as part of the GAB Atlas, which is another piece of work that was finished by GA a couple of years ago. In fact, we also undertook regional hydrogeological mapping for the major aquifers in the Galilee Basin, and we reviewed the existing knowledge for the Great Artesian Basin, which is in the Arckaringa. There was a lot of other work done as part of the Galilee Bioregional Assessment, and I won't be presenting on that today. And some of that, that work will be available shortly, early into the new year. It is largely complete. It's just in external review at the moment. So the work I won't be presenting today will be results from the surface water and groundwater modelling. I won't be presenting work around the landscape mapping that was undertaken. I won't be presenting anything around the impact modelling and risk analysis, and neither anything around the hazards analysis, hazards potentially associated with coal seam gas. So the Galilee Basin, it's so essentially this is a map of the bottom of the Galilee Basin. The browns represent areas that are relatively high, and these numbers are relative. These numbers are relative to sea level. So these are high areas near the basin margin. Purples represent the areas where it gets a lot deeper, so down to 2,500 metres in the Kobara Trough. But essentially there's three major depot centres. The Kobara Trough, which runs along this eastern margin. There's the Powell Depression over here to the northwest of the Warrego Fault. Then there's the Lavelle Depression over here to the northwest of the Cork Fault. There's a number of very significant structures along the basin margins and into the basin itself. I'm not showing all the structuring that exists, just a few select ones. There's some structuring along the eastern basin margin, which may be a series of faults. Some of these structures have been repeated active, had a long history of activity, and there's offsets along some of these faults of up to about 600 metres. The Bacolden Ridge, interesting series of structures in here, affected the depositional history of the Galilee Basin and basically segregates the northern Galilee, which is basically all this bit up here, from the southern Galilee. It's a slightly different history either side, but I'm not going to go into the details of that today. That's detailed in our reports. I'm about to show you a couple of sections through our regional geological model, and first one's going to be section A, which is cross section, and then a long section down the middle of the basin. Okay, so the cross section. So we're looking to the northwest. So there's the Galilee Basin margin. There's some of the key projects that we included in our modelling: Carmichael, Chinastone, Hyde Park. And they're where the coals come near surface. Great Dividing Range. There's the edge of the Eromanga, and then there's a series of ranges that comprise where the Hutton Sandstone and some of the lower sequences of the Eromanga Basin outcrop. Basically, these are where the recharge beds to the Great Artesian Basin aquifers occur, largely along that margin. And then as you head progressively westward into the basin, so the Eromanga, top of the Galilee Basin is basically along that blue line, base of that blue line. The blue's the Hutton Sandstone. This sequence is the Eromanga Basin sequence, then the rest is the Galilee. You can see the Kobara Trough, and as I said, it goes down, it's several kilometres thickness of sediments in there. Yes, and those interesting lakes that are perched between the two divides, the Eromanga Basin ranges and the Great Divide. They're unusual features. Okay, so now's a long section. So this is north and this is south, and you're looking westward into the Galilee Basin. And as you can see, this is the northern Galilee Basin. This is the southern Galilee Basin. And there's the Bacolden Ridge, and there's some significant offsets along that ridge, upwards of several hundred metres. Much of the Galilee Basin sequence has been eroded off. This is the Eromanga Basin sedimentary package, and it thins as you head northwards. Galilee's at its thickest in the northern parts. There's the Powell Depression, and again, the blue represents the base of the Eromanga Basin. There's significant sections of the Galilee Basin sequence missing from down here. You get a more complete sequence to the north. So I'm going to show you some more detailed examples of the hydrogeology of some of the different aquifers. We actually mapped the hydrogeology for about 10 different aquifers. So I'm not going to present the whole lot here today, as we'll be here forever. But I'm going to present one example from the Arckaringa Basin, which is the Hutton Sandstone Aquifer. And the Hutton Sandstone Aquifer is an important regional aquifer that makes up that is a part of the Great Artesian Basin. Then I'm going to present some new information around the Clematis Aquifer, which is the main aquifer within the Galilee Basin. It's the main regional aquifer. And I'm going to present some new information around the hydrogeology of the Upper Permian coal measures, along with some other bits and pieces as well. So now we're going to go have a look at the Hutton Sandstone. So as I mentioned previously, it's one of the iconic Great Artesian Basin aquifers. The Great Artesian Basin aquifers is this sequence in here, from the Hutton through to the Hooray and the Wyandra Sandstone. And the Ronlow beds occurs in the recharge area, along the margins of the Arckaringa Basin. And then there's another series of aquifers down here, the Precipice. It mainly occurs in the southern part of the Galilee subregion. So, the Hutton Sandstone. So this is the distribution of the Hutton Sandstone in the Galilee subregion. So this work was, some of this work, or much of this work, was compiled as part of the GAB Atlas, which was presented as a DGO lecture, I think, last year. So as you can see, the Hutton Sandstone is quite extensive, covering much of the subregion. It varies in thickness, so to the north of the Bacolden Ridge, it's up to about 150 metres thick. To the south is where it gets considerably thicker. So you had out here, this is where the Cooper Basin has been as a deeper centre for the Hutton, southern Galilee, and then extends across into the Surat over here. So where the overlaying the Hutton Sandstone is the Birkhead Formation, which acts as an aquitard to a degree. Where the Hutton Sandstone occurs in the Galilee subregion, it's mainly underlain by a shaly sequence called the multi-amber formation. So it's like a basal seal to the Hutton Sandstone. As I'll show, it's not always there. So the next slide area is going to focus in, well, where it's red. And basically, it's going to be, we're going to be looking at the hydrogeology of the Hutton Sandstone just in that area. And so here we go. So Hutton hydrogeology. So, as I mentioned, this is the edge of the Arckaringa Basin. The Hutton Sandstone outcrop is where you get that stippled area. So you've got patches of outcrop along the margin here. The Hutton Sandstone becomes buried as you go westwards. Once you're beyond this line, the Hutton Sandstone goes from largely an unconfined aquifer into a more confined aquifer. So in the unconfined aquifer, where it outcrops, where it's more acts as an unconfined aquifer, as you may recall from the one of the sections, this is basically a series of ranges, and so it's basically you've got an unconfined aquifer, and seems to be a groundwater divide developed along the crest of the ranges, and so you get some eastward directed groundwater flow towards the margin of the Hutton Sandstone, then you get some western directed groundwater flow into Hutton Sandstone into the Arckaringa Basin. So along the eastern margin of the, so where do this eastward directed flow out discharge? Well, one features of its discharge is this line of springs along the eastern margin, and then you've got another series of springs that occur as the Hutton becomes confined. You get some discharge occurring as springs. Just as the aquifer becomes confined, some of the groundwater goes into the deeper parts of the system, some of it discharges as springs. And it discharges in areas where the confining layer is either thin or where there might be some faulting. There are a number of reasons. One of the interesting findings from the work that we've been undertaking is that we did a revision of we had another look at recharge to the Hutton sandstone, and compared to previous estimates done a few years before, we realised that actually the Cenozoic cover, which is basically areas where you don't see this red outcrop, basically we realised that it actually impedes recharge to the Hutton sandstone, and so essentially our revised estimate of recharge to the Hutton sandstone was much less than previously thought by about 25%, 30%. And why is that important? Well, it has implications for the water balance to the Hutton sandstone aquifer and other aquifers that make up the Great Artesian Basin. And this is that was one of the discussion points for a workshop that was held last year that was looking at the Great Artesian Basin aquifer in Canberra. And so, again, as I said, confined system. You get local groundwater system developed in this outcrop area. You get a confined, more regional system where it's confined. Generally, the flow's westerly. And as you head progressively westerly, the aquifer can become artesian. And for those of you may not know, artesian is basically where the groundwater levels are higher than your natural, will be higher than your natural ground level. So essentially, the bore will flow to surface. Okay. So, one question you can ask is there? Did I miss a slide? No. Okay. One question is there? What's the potential for connectivity between the Hutton sandstone and underlying aquifers in the Galilee Basin? Well, as I mentioned previously, the regional aquitard that lies below the Hutton sandstone in the vicinity of the Galilee Basin is the Multi-Amber Formation. So where this sort of orangey browny colour is, that's where we mapped the Multi-Amber Formation to occur. And so it outcrops along the eastern margin here, and then it's buried by the Hutton sandstone and other as you head westwards. But there's the Galilee Basin margin. The Hutton the Multi-Amber stops short of the margin, and so essentially what you get, the areas that are green, is where you have other formations in the Galilee Basin, such as the Upper Permian coal measures, the Clematis aquifer. This is where these sequences can directly abut underneath the Hutton sandstone, and that occurs in an area where there's significant faulting along the margin of the Galilee. The Multi-Amber's missing. So one of the questions, is there evidence of leakage from Galilee into the Eromanga Basin? Well, I could say it's a bit circumstantial at the moment, but we think so. So essentially, where the red dots are is where salinity measurements in the Hutton sandstone were relatively high. So down here, Hutton salinity greater than 960 milligrams per litre. So this is essentially, they tend to be clustered where you get quite a clustering where the Multi-Amber disappears. Not always the case, but there is a significant cluster here. So we postulated that could be evidence for leakage from Galilee Basin aquifers into the Eromanga. And a recent paper also noted that there was anomalous gas in the Hutton sandstone in this area, and they thought it could be from gas leaking from a source from the Galilee coal measures. And interestingly, I heard a similar story from one of the CSG at a workshop yesterday. Someone who had been drilling CSG, exploring for CSG in this area down here, thought that the gas had leaked from the coals up into the Hutton, or that was his reasoning why his gas contents were so low. I liked it. It agreed with us. So next we're going to look at the main regional aquifer that occurs in the clematis in the Galilee Basin. It's called the clematis group aquifer, which is here. And again, it outcrops along the Great Dividing Range, which is along here. It's at its thickest in some of the depot centres, such as the Kibara Trough. It's thicker to the west of the Warrego Fault. There's some interesting erosional holes around the Barcaldine Ridge and along the western margin here. And the hydrogeology, I'm about to zoom in at this area here for the next slide. So the clematis hydrogeology, this is about the first time it's been mapped regionally. So again, you get the potential for groundwater flow is from the high areas, down, from the reds to the blues. So essentially what this is these are contours of the hydraulic head relative to sea level. And so this is where it's high, this is low. The potential for groundwater flow is from the high areas to the lows, as indicated by these arrows. And so one of the interesting features in the clematis compared to the Hutton, the Hutton had a groundwater divide. So to the north of the Barcaldine Ridge, the Hutton, so in the clematis you get this groundwater divide. And it's, well, in the Hutton sandstone that occurred in the outcrop area, but here this groundwater divide is more basin centred, away from the outcrop areas, which is this red bit, where the red stippling happens to be. So you tend to get flow eastwards towards the Galilee Basin margin and then westwards into the Galilee Basin. And the eastwards flow is heading towards, in particular, heading towards the Carmichael River and these springs here, which are known as the Doongabulla Springs. So basically groundwater and even recharge along the margin here gets redirected towards the springs here. To the south of the Barcaldine Ridge, it's more what you would expect. And this in the early days was quite a surprise to a few people. We didn't expect that. We expected to see groundwater flow occur from the basin margin into the basin. So that was a bit of a surprise. So the next one we're going to look at is the Upper Permian coal measures. Now, as I mentioned previously, the stratigraphy of the Upper Permian is quite complex and includes a number of stratigraphic units. There's a large variation in lithologies, which has a bearing on how the hydrogeological systems work. Again, it outcrops along the eastern margin, east of the Great Dividing Range. Skipped. So again, outcrop is along here. Those white dots are where the coal developments happen to occur. So again, along the eastern margin. It's at its thickest around the Kibara Trough and also in here in the Aramac Trough. It's quite thin to the south of the Barcaldine Ridge, down to about 50 metres. And a lot of the sequence is actually missing down here. And again, there are erosional holes along the western margin and a bit onto the Barcaldine Ridge. There's some other work that's been going on concurrently with the Galilee Bioregional Assessment independently by University of Queensland. Some people from GA have been involved in it, and basically there's potentially some significant revisions to the Upper Permian coal measure stratigraphy is underway, and some of that work was recently published in Australian Journal of Earth Sciences. Another thing that is of interest is how thick is the Upper Permian coal measures, and again it thickens as you head westwards. It's a reason why the coal mines are here is because the cover is relatively thin. It's anomalously thin over the Barcaldine Ridge. Coal seam gas, again this is a map of the average gas content. You get higher gas in this central region where it's red. Blue is where you've got low gas contents. Gas is generally found between, so the coal seam gas, they're generally tapping the coal measures between 800 and 1200 metres. Gas isotopes suggest it's biogenic. We suspect there could be some biogenic structural control in the CSG, like gas distribution. For instance, this fault here, it's not too bad on the northwestern side of the fault, then it really drops off on the other side. Essentially what this map suggests is that future CSG development will occur where there's higher gas contents, less likely up here, more likely in here. So the hydrogeology of the coal measures, and again, like with the clematis, you've got this basin-centred groundwater divide with eastward directed flow towards the basin margin, and there's some springs along the basin margin that are thought to be sourced from the upper Permian coal measures. Westward flow towards the basin margin, westward flow towards the western basin margin. Down here, again, there's potential for groundwater flow from basin margin and inwards. So just to summarise some of the key points, unlike what we saw in the Arckaringa Basin, in that part of the Arckaringa Basin that occurs in our area of study, there seems to be this basin-centred groundwater divide that's not necessarily associated with outcrop, occurs in both the upper Permian and the clematis. It's a common feature to all the confined aquifers in the Galilee. Groundwater flow potential focuses, also the groundwater flow potential east of this divide focuses towards the same area. So here in the clematis it's focusing towards the Carmichael River. Again, these springs occur just to the south here. So there's a general focus towards the same area. Whereas down south here you tended to get more flow from the margin inwards. So why are these findings important? Well, they're important to the Galilee Bioregional Assessment. Well, they're important because they show how the Galilee groundwater systems may work and interact. This work has defined the configuration of the aquifers. It's defined some major potential flow barriers and compartments that may occur in the Galilee Basin aquifers. And knowing where they are is quite key to how you manage water resources from these aquifers, can be key. This work has provided an input to the groundwater modelling, and it's also providing an input to help understand the potential impacts from those coal developments to water-dependent assets. We also identified some knowledge gaps. These include, there's actually knowledge gaps around the recharge processes for the Galilee Basin, as well as the Arckaringa Basin aquifers, but particularly more Galilee. There's some evidence to suggest that there could be some groundwater exchange between Galilee Basin aquifers and the Arckaringa, but how much actually occurs, I don't know at the moment. How much discharge actually occurs from the Galilee aquifers along the eastern margin, needs to be better quantified. How much discharge occurs towards the Ballyanda River. Aquifer compartmentalisation. Are there other structures that influence groundwater flow? Some of our data gaps include, we think that there'd be some advantage to having more hydrochemistry, environmental traces, stable isotopes, some geophysical surveys. We think the geological mapping, there needs to be some more detailed geological mapping in the Galilee outcrops. There's some more detailed mapping would help. And so some of our conclusions include, our work here represents the first regional conceptualisation of the Galilee hydrogeology. Our conceptualisation outlines some of the key features that we think influence groundwater flow. There seems to be some differences between the groundwater systems in the Galilee and the overlying Arckaringa. We've developed a geological model, and that provides a framework for the Galilee hydrogeological model and to investigate future questions around aspects of geology and hydrogeology. Our work has provided an input to is being used as an input to the assessment of impacts and risks in bioregional assessment. It is being investigated to assist in management of water-related assets, aside from what's going on in Galilee BA. I know that Queensland agencies are looking at it as well, and it provides some direction for future investigations. And so where can you find all this work? I mentioned it had to be transparent. Our work had to be transparent and available for all. Well, you'll be able to find it at this website, bioregionalassessments.gov.au. It's likely some of our reports are already available through this website. The rest will become available shortly, most likely by early next year. And this is where you can get data, maps, reports, model codes, the whole lot will become available. So thank you. And any questions?